Welcome back to The Explainer. So today we're diving into what is essentially a magic trick, one that's hiding right inside our data. I want you to just take a look at this perfectly predictable, beautifully smooth business cycle. Look at those graceful peaks and valleys. I mean, it's exactly the kind of reliable, steady economic rhythm that forecasters literally dream of finding, right? Picture this. You're an analyst, and you're relying on this perfectly smooth, cyclical shape to make critical financial forecasts. You might look at this and instantly start writing your report. You'd say, okay, here's the boom, and over here is the bust. The market is very clearly following a 5-year periodic cycle. And based on that, you'd allocate capital, manage your risk, and make massive, high-stakes decisions. All of it based entirely on the assumption that this shape represents a genuinely forecastable system. Let's be honest, it is incredibly tempting to trust a curve that looks this good. But here's the brutal truth. It's not. No, it is pure, unadulterated noise. If you were betting on that cycle, you were betting on a ghost. The data generating that highly attractive curve is actually just a random number generator. There is zero underlying economic reality driving those waves. What we were just looking at wasn't a business cycle at all. It was a completely artificial pattern. And this perfectly captures our own psychological vulnerabilities as forecasters. On one side, we have the analyst's story. As humans, we are completely hardwired to see patterns. When we see a smooth, rolling curve, we immediately invent a convenient story for it. We just assume there's some underlying economic mechanism or a forecastable trend at play. But on the other side, we have the mathematical reality. And in this case, the reality is that the data is pure noise. It's just an aggregation artifact. It is absolutely crucial that we recognize the tension between these two perspectives, because confusing the analyst story for the mathematical reality, that can completely destroy a forecasting model. So let's jump into our first section and reveal this pure noise, breaking down exactly how this illusion gets manufactured step by step. Let's actually run a quick chronological experiment. Step 1, we generate 2 entirely independent series of data made of pure noise. Think of it like just flipping a coin or rolling a die over and over again. There is absolutely no connection between the data points. Step 2, we apply a moving average. We average them out or smooth them, which, is a super common technique analysts use to try and find a signal in messy data. And then step 3, we watch as apparent structure emerges. By simply passing that completely random, independent noise through a smoothing filter, the data totally transforms. The jagged edges disappear, and suddenly, boom, a perfectly smooth, wave-like structure appears right before your eyes. Which brings us to our next section, the Slutsky Effect, the formal name for this rather dangerous data phenomenon. So the Slutsky effect is defined as the phenomenon where applying moving averages to aggregate series creates an artificial, cyclical structure out of random noise. I really want to emphasize this point here. This cycle is a mathematical artifact of the aggregation itself. It's an effect of the moving average. It is not a genuine periodic process happening in the real world. If you smooth random data hard enough, it will inevitably start looking like a structured business cycle. But that cycle is absolutely not evidence of a forecastable system. And that brings us to a pretty massive problem. I mean, if smoothing can just manufacture apparent cycles from pure noise, how can we ever trust our own charts? How do we mathematically prove a cycle is just a trick of the light, rather than a genuine real-world mechanism? Well, that takes us to Section 3, Diagnostic Reality Checks. Let's look at the statistical tools we need to unmask the illusion. This breakdown brilliantly illustrates exactly how we catch the ghost. We use 2 diagnostic panels, the autocorrelation function, or ACF, and the periogram spectrum. When we look at our raw, unsmoothed data, the ACF is completely flat. There's no structure. And the periogram shows pure white noise. This is reality. But then, look at what happens with the smoothed data. After we apply that smoothing filter, the ACF suddenly shows artificial peaks, and the periogram develops a fake cyclical structure. These diagnostics explicitly show us how the structure only develops after the moving average is applied. The filter literally built the cycle. So, the crucial point is this, and it's a big one. Do not mistake the filter's response for the world's structure. This is perhaps the most dangerous trap in all of time series forecasting. There is a massive, massive temptation to over-smooth data until it tells the story you want to hear. But you have to remember the distinction between an aggregation effect and a genuinely periodic process. Now, the takeaway here isn't that you should never smooth your data. Smoothing is incredibly useful for signal extraction for sure. The point is that you must never confuse the artifact of your own math with reality. Let's move to Section 4, Rules for Safe Smoothing. Let's set up some guardrails. Here is your safe smoothing checklist. 3 unbreakable rules. Step 1, keep the raw series visible beside every smooth series. Never just look at the attractive, smoothed curve in isolation. Step 2, run your ACF and spectral diagnostics on the raw data and the transformed data. Don't just run them on the pretty curve. You have to compare the before and after to see if the structure was actually there all along or if your filter just created it. And step 3, validate any discovered cycle out of sample. Remember, a pattern created by a mathematical transformation is absolutely not a real forecastable mechanism. If the cycle suddenly disappears when you look at new out-of-sample data, it was a ghost. I want to leave you with this really powerful mantra drawn straight from the core principles of forecasting. Every visual pattern needs a diagnostic, not a story. Next time you see a beautifully smooth cycle on a chart, stop yourself before you start inventing a narrative about market forces. Run the math. Check the ACF. Look at the spectrum. If you want to see this magic trick unmasked firsthand, I highly encourage you to check out the MMTSS Pro Notebook. The real value here is in running the annotated code experiments for yourself. You can generate the independent noise series, apply the averages, and watch the reproducible ACF and spectral proofs develop that apparent structure right on your own screen. You'll get hands-on experience with the safe smoothing checklist we just walked through, which really cements these core principles of forecastability. So I'll leave you with this final thought to chew on. The next time you look at a perfectly smooth trend in your own models, are you looking at reality or are you just staring at your own filter's reflection?